All right, well, here we are at chapter 9, which you can see is all about right triangles. So this is going to be a really fun chapter, especially if you're good at your algebra. Notice that we are skipping section 1, and that's because all of the review that we've been doing with radicals is everything that they did in section 1. So we don't need to go do it again, since we've already spent so much time on it. So we're going to jump right into section 2, which is basically an introduction to circles and arcs and sectors. Let's get started. I think you guys remember the two formulas that are associated with a circle. The first one being to calculate the circumference going around the distance around the circle, which is 2 pi r, r meaning the radius of your circle. Some people think of the formula for the circumference as the diameter times pi, and that's okay too. Either way that you think of it is fine by me. And then the area formula, which is pi r squared. So really make an effort not to get these confused if you tend to do that, because we'll use them a lot in this section. Okay, so talking about an arc. So the definition of an arc is if you have a circle and you pick 2 points on that circle, all the points that are between those 2 points on the circle are considered part of the arc. So if we start here at C and go all the way here to B, that is the arc that they're talking about. So all these points. We're not talking about in the inside of the circle, we're actually talking about on the circle right here. Okay, and when we name an arc, we use a little arc symbol above the 2 letters, the 2 endpoints of the circle. And some of you might be thinking, well, why didn't I go around this way to talk about that arc? And I could very well have done that, but for right now, we're only going to be concerning ourselves with the arc that's less than 180 for right now. We will take a look at how to deal with those arcs that are more than 180 at a future time. Okay? So what can we do with an arc? Well, we can always figure out the measure of an arc. And the measure of an arc is going to be found in degrees. So what you do is you basically connect the 2 endpoints to the center, and you get these 2 radii, and you look at the angle that's formed with those 2 radii. And whatever the measure of that angle is the same for the measure of the arc. So the same number of degrees that it occupies, that's how you would define it. So for example, if they told you that angle AOB, this angle right here, is 90 degrees, then we also know that the measure of arc AB is 90 degrees. So whatever this central angle measures is the same as the measure of your arc. And that's going to be really important to remember. Okay, so that's not too bad. The next thing that we can solve for, looks like I have to erase my screen, there we go. The next thing we can solve for is to figure out the length of an arc. So there is a difference between a measure of an arc and a length of an arc. So the measure of the arc talks about the number of degrees that it occupies, basically. But the arc length is kind of considered the distance that you would travel walking on the circle from one point to the next, if that makes sense. So we kind of think of it as a fraction of a circumference. So it's part of the circumference of all the way around a circle. So to figure out the arc length, what you're going to do is you're going to take the measure of the arc, that's in degrees, remember, and divide it by 360 because there's 360 degrees in a complete circle. So we want that fraction of the circle, right? So we take the measure of the arc divided by 360 and multiply by the circumference. So if we look at this example, this angle right here measures 30 degrees. So that means this arc, AB, measures 30 degrees. But if I wanted to figure out the arc length, I'm going to have to plug that into the formula. So I take 30 divided by 360 and multiply by the circumference. Well, since the radius is 5, the circumference, 2 pi r, is going to be 10 pi. At this point, now you just have to simplify your fractions, and we're going to leave our answers in terms of pi, unless they specifically tell us to round. So that means 30 divided by 360 is going to be written as 1/12, and then the 10 and the 12 can simplify to 5/6. So the arc length is 5/6 of pi, or 5 pi over 6. A lot different than the 30 degrees when we were talking about the measure of the arc. All right, so that's arc length. Now let's talk about what a sector is. A sector is just a portion of the circle that's made up of 2 radii. So here's a radius, here's another radius, there's my 2 radii, and then the arc joining them, and then all these points in between, so that's why it's all shaded. So this whole thing right here, that's my sector. Okay, so if you think about it, a sector is kind of like a piece of pie or a piece of pizza or a piece of cake. I guess I'm hungry because I keep talking about food. It includes all these points that are in there. So we're talking about area, right? So they're going to ask us to figure out the area of a sector as opposed to the length of an arc. It is going to follow the same formula, however. So we are just taking a fraction of the area of that whole circle. So we would once again want to take the measure of the arc divided by 360, because that's going to give us the fraction of the circle. But this time we're going to multiply by the area. So let's take a look at this example. It says find the area of sector ACB. By the way, there is no symbol for a sector, so we just have to write the word sector in front of the 3 letters. And the middle letter should always be the center of the circle. All right, so they've given us that this angle, this central angle right here, is 120 degrees, and we know that the radius is 4. So if we plug this into our formula, the measure of the arc is also going to be 120 degrees, and we divide it by 360. And then we multiply by the area, which is pi r squared. So we simplify. 120 over 360 is 1/3, and then 4 squared is 16. So there's nothing we can really do with the 3 and the 16, but we will write it in a neater way of writing 16 pi over 3, or 16/3 pi. Okay? All right, next. What's next? Oh yes, a chord. I know you guys know what a chord is, but we need to officially define it. It's a line segment that joins 2 points on a circle. So these 2 endpoints of our segment have to be points that are on the circle. They can't be outside the circle, they can't be inside the circle. And you can think about the longest chord would have to go through the center. So the longest chord of a circle is called the diameter. We have another type of angle. I've mentioned before about the central angle, and that was an angle whose vertex is at the center. But we have another special angle, which is called an inscribed angle. And that's an angle whose vertex is on the circle. So you can see angle EFG right here. The vertex is point F, which is actually on the circle. And then the sides of the angle are the chords of the circle. Okay, so these 2 sides of the angle have to go through the circle at some point. You can't have one of them being off out here and being tangent or something. Okay, so that's an inscribed angle. And we want to know how to figure out the measure of an inscribed angle. And the nice thing is it's a pretty easy formula. You're just going to take half of the measure of the arc that's formed. So every time you have an inscribed angle, these 2 chords are going to cut off an arc. So here's the arc that it cuts off. And so you look at the measure of this arc, in order to look at the measure of this angle. And this angle is going to be half of this arc. Okay? So half of whatever this arc is going to be angle F. So if arc GE had a measure of, say, 50 degrees, then angle F is going to be half of that, which is 25. We could also go the other way. So what if we knew that angle F measured, say, 40 degrees? Then we would then be able to know that this arc is going to be twice that. So if this angle is 40, then this arc is going to be 80 degrees. So here's another example. Hopefully you've already figured this out. If this arc right here is 130 degrees, we can use our formula and take half of it, and that angle is going to be 65 degrees. So this information will be useful if they ask you to figure out the measure or the length of this arc. Maybe they tell you this angle instead, so you'll have to double that to get the arc measure in order to plug that into your formula. All right, that's it for our introduction to circles. I know it's kind of random. We're not talking about right triangles yet, but we had to get through all this material because we will be using it later on quite a lot. All right, hope it wasn't too bad for you. I will see you later.